Hi, friends, Glenn Kirshner. No, that's not me. Glenn Kirshner, that's that lawyer guy. Yeah, I guess this is a different, right, we're not studying court cases here. No, we're looking at, if we know the value of A in the AX squared plus BX plus C model, if we know that number, and we have the vertex HK, so if we know A, and if we know HK, then we have the roots in 5 seconds or less. And I'd like you to have some practice with that. So I'm going to do 6 problems, and you can pause the video each time. I'm just going to do them quickly and say very little about it. And then the 7th one, the very last one, I'll explain what's going on. And I suggest you look at that explanation because it might help you understand solving equations of any type. All right. So once I get on a roll here, no, I can't get on a roll. Somebody stole my science card. I'm still upset about that today. That means I got to pick up the computer and move it. That always carries risk because sometimes I forget to put the camera where it belongs. I think we can see things here. And keep in mind that roots are y values of 0. All right, so here's vertex 5, -11, a value of 2, and I'm dotted line y equals 0, but it works for any constant. We can solve these equations for any constant in 5 seconds or less. So I have 1, 2, 3, 4, 5, 6. I'm going to do them. You can pause the video and try to see the pattern. I've tried to write x equals in a helpful position to see the pattern. And I'm just going to do all 6 very quickly and then explain the process on problem number 7. All right, so here we go. I got the a value, I got the vertex, so I guess I've got everything I need, plus minus the square root of 11/2. Next one, what have I got? Y0, A3. Oh, I think I have 4 plus or minus the square root of 7/3. I think you can already see this one. Oh, y equals 0. Well, I'm imagining things. That's not going to intersect here. 2 plus or minus the square root of 19/5. But I'm imagining things. My God, what an imagination. That quadratic actually, instead of going up, goes down. Oh, I think I'm measuring from 7 plus or minus the square root. I guess I got to travel 21 units down with a multiplier of -3. I'll make it +3 because these are real roots. Let's do the next one. Imaginary roots. No, this doesn't equal 0 this time. Oh my God, how far is it? 20 to -35. I better say 55 units of change, yeah. But anyway, I'm measuring from -3 plus or minus the square root of 55/2. I mean, it's really -55/2, right? But I'm sure you can see that it's it's real answers here, so we don't have a negative square root in there. No. And the last one, 5 seconds or less. I think we're doing it. Looks like, I'm imagining that the quadratic has a sign change. Oh, did I know that I squared? Oh, yeah, that has a tendency to change signs of whatever number is in front of it. Oh, where am I? I digest. 93, x equals. X equals -93. I'm measuring from there, plus or minus the square root. What is it? 15 divided by 4. But you know what? I think you're imagining things. All right, so let's go look at why we can say that and say that quickly with one last example. All right, well, let's solve this equation by putting it into graphing form. 3, -5, 3, -5. Yeah, that makes 2, 0 squared -5. Yes, that's a minimum. Oh, yeah, it doesn't get any smaller than that. Range y greater than or equal to -5. I digest, or maybe it's digress. Just having a little fun. Something -5 equals 0. Let me think about that critically. What -5 equals 0? Oh, good thing I got an eraser here because I figured this one out. This thing in the box, what's in the box, I think I know what it has to equal. I think it has to equal 5. So it probably makes sense that that's our next line of work. What's that 5 represent? Well, we're trying to get to 0. trying to get to 0 from -5. I have a feeling our x value, we have one of them over here, right, to get to that x, and there's one x over here. So maybe I should write this as a number line. And that x value was, I think it was 3. I've already lost, yes. And this is a y altitude of -5. Got to get a negative in there. Here, I'll do a better job of writing that. I'm on a roll here. No, I'm not. I lost my science card. Negative, and I got to get to 0. You know, I think I have to go up 5 units in order to get from here to there. I think that may be what that's telling me. Of course, 2 times something equals 5. Oh, I got to think about that one pretty. Jeez, well, 2 times what equals 5? You know, I think it's 5/2. Yeah, I figured that one out. So I guess my next line of work is x minus 3 squared equals 5/2. Yeah, because if I'm multiplying 5/2 by 2, if I multiply that by 2, I get the 5 units of change I need. Well, that's good. Let's move that a over 2 equal here. That out of the way. Mo, something squared equals 5/2. I got to think about that critically. What squared equals 5/2? You know what? That's a rectangle. I want to get a square. And I need 5/2 here. So I'm trying to figure out what that distance is. You know, I think it's the square root of 5/2. Yeah, I think it's plus or minus. Yeah, because I think if I square that, I get that. And I think, if I'm not mistaken, that x minus 3 has to equal plus or minus the square root of 5/2. And now I've got something minus 3 equals plus or minus the square root of 5/2. Well, I think I'm measuring from 3, and I think I got to do 3 plus something to get to this second x, and maybe 3 minus something to get to this first x, so that I can figure out what that x value is. That gets me 0. And it sure looks like it's, yes, I got to write that. And I think those are real roots. I think this parabola, which was at a height of -5 at vertex, will, yeah, I think it's going to go through 0. So I guess the last thing we should do is actually see if these numbers work. And what happens when I use this answer in this equation. And so I guess I'm going to want to really write the 2 out here, and the 3 plus or minus the square root of 5/2. And the first thing I see is, I don't think I have to do 3. And I think I can get rid of +3 and -3 with just an eraser. And I suppose if I square a positive or a negative, I can kind of ignore that. I get a positive. And if I square the square root, I get what's inside. And if I double something divided by 2, I guess I get the numerator. Then 5 minus 5 is 0. I don't think I should see blanks on your next test. If I do, I have to assume probably that you didn't look at the video. Because I think there's a pattern here, and I think everybody's capable of seeing it. And it does take effort. Put in a little effort, and then you got your roots at your fingertips. But you got to give it a little bit of practice and thought. And it's nice when you get something down mathematically that you have some ownership of. So I hope you play this enough. And if it doesn't make sense to you, stop looking at the video, let your brain rest, come back at it tomorrow. And there aren't too many things that I've looked at mathematically, learning this as an adult, that didn't take about 4 days of a few minutes of consideration each day. That's how I learned this. You know, I think about it and go, I don't quite get that. Okay, shut the book or stop thinking about it, come back and let me think about that, and maybe get a little further along. Usually about 4 days. Very helpful for an awful lot of concepts in math. So I suggest you try that. Oh, I don't need to walk around with this anymore. I can shut it down. There we go. See you in class.